Hey y'all! Video 16, let's go and roll the dice. So here's the situation. Your friend Bob, he says he'll give you $1 million if you guess the correct number for the following scenario. Bob rolls 2 dice and adds up their values. What number would you bet on? Now in class we actually do this and I give out $1 million to the person who wins. And what number would you bet on? Is there something that makes more sense than another thing? Well, we're going to find that out today. So if we were actually in class, what I would do is I'd get you in groups and you'd roll 2 dice and then you would add them up. And I did this with a class and I've actually got their picture. I think this is the first time I taught this class. I got Jose and Eddie and Eduardo, Megan, Oliver, Cole, Cody, Emily, Marco, and Veronica in the class. And so basically you got to think about 2 die and what are they going to add up to? Well, what are our possibilities? Well, the lowest you could get on a die would be a 1, just kidding, yeah, a 1, and then another 1. Well, what's 1 plus 1? Well, that's a 2. So the lowest you could get when you roll 2 die is a 2. What's the highest you could get? Well, you could roll a 6 and you could roll a 6. So the highest you could get is a 12. It's impossible to get a 1. It's impossible to get a 13. So I don't know, I set the clock for like 5 minutes and people calculated. They added up their 2 die and then they made a mark. Like for example, Eddie got 0 2s, he got 2 3s, he had 4 times, added up to 4, 6 times, he had a situation where his die added up to 5, he had 3 times when it added up to 6, he had a whopping 11 times when his die added up to 7. Okay, so I added those all up and as a class, this is crazy, but we only had 16 people get a 2, and obviously we got 0 people get a 1, and then 34 people had their die add up to 3, and then etc., etc. So I put that in a histogram and you can see that there's kind of a resemblance of a normal curve going on here. And what would you assume would happen if we were to do this an infinite number of times, or even not an infinite but 1,000 or 500,000, or we were to get all the schools in the country to do this? Well, this is exactly what would happen right here. We would have a perfect normally distributed curve. And it's interesting to look at this. Obviously it's got that bell curve going on, but which one is the most likely? Well, it looks like if you said 7 to that question, you were the smartest because that's the highest probability. In fact, going over here, it looks like it's a higher than 16% chance that you'll get a 7 when you roll 2 die and you add them up. If you said something like 2, that looks like a little bit more than 2% chance of getting that. And so that wasn't the smartest decision, but I've actually played this game with students before and it can be a 2, right? That does happen. So you're not guaranteed to win if you say 7, but you're more likely to win. You've got a higher probability of being correct. So I want to take a look at this table right here. This is kind of interesting. What are the possible outcomes that we can have? Well, what are the possible things we can score on 1 die? Well, obviously we can get a 1, we can get a 2, we can get a 3, all the way up to 6. And what are the possible scores on the other die? Well, again, we could get a 1, a 2, a 3, a 4, a 5, and a 6. So this table right here basically says, all right, well, what if I roll a 1 on this one and a 1 on that one? Oh, you'll get 2, right? Add them up and you get 2. Well, what if I got a 4 on this die and I got a 5 on this die? We'll add those up and you got a 9. So this table right here basically represents all the possible outcomes you can get when you add 2 die. Well, how many possibilities are there? Well, this is a row of 6, and this is a row of 6. So we've got a 6 by 6 box, which is 36 outcomes. All right, so let's get these done. What is the probability that the numbers add to an odd number? Well, we're out of 36, right? And how many of them are odd? Well, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's 18 over 36. Press enter on your calculator, get math fraction, like I taught you in that video, and you get 1/2. And that totally makes sense, that half of our numbers here would be odd and half would be even. What's the probability that the numbers when you roll 2 die add to either 3 or 6? Well, here's my 3 and here are my 6. And how many are those? That's 1, 2, 3, 4, 5, 6, 7. So that's 7 out of the total 36 options. And that's it, because we can't reduce that. What's the probability that when we roll 2 die, we have our numbers add to 7? Well, there's a ton of 7s. That's 1, 2, 3, 4, 5, 6. That's 6 over 36. Reduce that fraction, and it's a 1/6. That's a pretty good chance. 1 in 6 chance of getting a 7. All right, next one says, what's the probability of getting 2 numbers that add to a number higher than 7? Well, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 out of 36, which reduces to 5/12. All right, last one here. What's the probability that the numbers add to a number divisible by 4? Well, when I say divisible by 4, I mean you can divide it by 4 and you don't get a fraction. So those numbers are 4, 4, 4, and 8, 8, 8, 8, 8. And what about 12? Yep, we can do that. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 9 out of 36. And what does that reduce to? That reduces to 1/4, of course. Okay, where's the next button? This is hard to watch, I bet. You're thinking, Ms. Sorensen, what is going on here? Well, you know what? That's the end of the video anyway. So, the end. Thanks for watching. Life is good. Don't forget to do your assignments. Bye now.